Hello everyone, today we're looking at Unit 6, Lesson 8, Cosine Law. So cosine law is another law that we're going to use when we don't have a right angle, similar to sine law. We're going to set up this first example and take a look at maybe why sine law cannot be used in this case and why we need another law called cosine law. So in triangle ABC, let's draw a triangle ABC. Angle A is 25 degrees. Side length B is going to be 12, so remember that's across from the angle. And side length C is going to be 14. Find side A. So we'll just put a lowercase a here. So if we were going to try to do this using sine law, which we talked about in the previous day's lesson, remember sine law, if we're trying to find a side, is A over the sine of A. Okay, and if we were seeing if we could use any of these ratios, we have those three that we were trying to work with. So if I set up for A at least, because that's what we're trying to solve for, we'd have A over the sine of 25. If I wanted to use the side angle pair for B, then I would have 12 over the sine of, I don't have angle B, so I would have that missing from this ratio. And then if I wanted to try to use the side angle pair for C, well, I have 14 for my side length, but again, I'm missing the angle. So you can see in each ratio, there is missing information, right? I need a ratio that at least I have both the angle and the side. So there is missing information. In each ratio when I try to use the sine law in this case. So this goes to the point here. Okay, sine law cannot be used in this case because we do not know or cannot determine an angle and the opposite side pair, right? We don't have enough information, so we can't use the sine law. So this is where we're going to introduce the idea of cosine law. So cosine law, you can see, is a longer formula that we're going to use, but there's a pattern to the formula if you become familiar with it. Okay, first, if we look at cosine law, a couple things I want you to notice. We're still working with the same kind of triangle with angle A, angle A, B, and C, and then their corresponding opposite sides. Remember that they have corresponding sides. Okay, the side opposite an angle is its corresponding side. There's some patterns that you should notice in this formula. So when we don't have A, B, and C, say they put X, Y, and Z as your variables on your triangle, you still know how to use the formula. So here you've been given three versions of it. It's just, are we trying to find side length A, B, or C? But you can see the pattern of how they're set up is all the same. Some things to notice here. If we look at this bottom one, hopefully we can see that this looks very familiar to Pythagorean theorem. In our cosine law, the first three terms will always look like this. It's just a matter of this is the side you're trying to find. So this is our So whatever's on the left of the equal sign, this represents our unknown value. Okay, that's what we're trying to find. So that's why that always goes on the left. And then the other two sides come on the right side of the equal sign. Plus, you have a bit more here. And if you look at the triangle, I like to draw, similar to how we did with our sine law, if I was trying to find that plus more, you can see that if I was to make another circle like I did with sine law, that plus more, I can kind of draw a little circle or triangle pattern right here. So when we're trying to find, say, side length C, I know that I'm going to use A and B set up like a Pythagorean theorem, and then that plus more piece is going to come from everything that's inside this circle. So just know the pattern for this formula. And we're going to practice that using this kind of circle triangle to help set up our formula. So if we revisit the triangle that we had up above, let's see if we can now find side A using cosine law. So once again, I'm going to circle to start. I'm going to circle. These three are what I have to work with, and I'm trying to find side A. So if I'm trying to find side A, let's use, right from our cosine law, we're going to use A squared because that's what my unknown value. That's going to be equal to the Pythagorean theorem piece where the other two sides are added and squared. And then it's going to be that plus more. So it's going to be minus 2. And then the sides I have in my triangle, I'm going to label these so we can see. We have B and we have C. So minus 2 times B, C. And then this dot here, oh, I meant to mention that. This dot, remember, means multiply. Okay, so we're going to multiply by the cosine of, again, the angle that's in this triangle circle we've created. So the cosine of A, cosine of 25 degrees. Sorry, I wanted to write that as the cosine of angle A, and then we'll fill in our numbers in a minute. So it's the cosine of A. Okay, so we're going to fill in what we have here. Again, we're trying to find side A. So B would be 12 squared. C would be 14 squared. Minus 2 times B again is 12. C is 14 times the cosine of A, which is 25 degrees. When we go to calculate this, we have to keep in mind our order of operations. Okay, all of this is connected by multiplication. So we need to make sure we calculate that piece all together before we worry about the subtraction. So make a note here, we're going to calculate all together. Okay, so if I do 12 squared plus 14 squared, well, 12 squared is 144, 14 squared is 196. Now that piece above, that plus more section, if we were to calculate 2 times 12 times 14 times the cosine of 25, we should end up with 304, and I'm going to leave those 4 decimal spots like we have been, 0.5194. Okay, now I can combine all those because they're just plus and minus. So then you should get 35.4806. And the last step algebraically is we're going to take that square root to isolate A. So you should get 5.9566. Right, and we'll round this to 1 decimal spot as our final answer. I just wanted to leave those 4 numbers to show that we should not round it to the end. So we'll say round to 1 decimal place. So A will equal, well, if I round to 1 decimal place, it's actually going to end up rounding up to 6.0, and our units are meters. Let's try a few more with cosine law. Before we do, we're going to rearrange cosine law in order to solve for an angle. So remember, with our sine law, we had used this version if we're solving for a side length, and use this version if we're solving for an angle. So we're going to rearrange cosine law so that we have something to use for an angle as well. Okay, so just like we calculated all of this together, we're going to move this part all together. And then we'll worry about trying to break it apart once we have it by itself on one side of the equation. So I'm going to move this whole piece over to this side of the equation, and I'm going to move the A squared over to this side of the equation. Okay, so to move that 2bc over, we're going to add it. So we're going to have a plus 2bc times the cosine of A. That's going to equal b squared plus c squared. And then I'm moving the a squared over, right, by subtracting it, minus a squared. Okay, I'm trying to solve for the angle of A, so that's what I need to isolate. I need to isolate my capital A in that case. Okay, so I'm going to start by now, I need to separate this big piece we moved over here. So I'm going to divide by 2bc, because 2bc is being multiplied by the cosine of A right now. So to move that 2bc, I'm going to need to divide it. So we'll have the cos of A equals b squared plus c squared minus a squared all over 2bc. Okay, now if we need to isolate A, need to isolate capital A, we're going to have to do the cos inverse to move that cosine part over. I'm just going to come up here. So then we'll have the angle A equals the cos inverse of b squared plus c squared minus a squared all over 2bc. Okay, and now we have a formula we can use when we're trying to find an angle. So we're going to repeat that process with some values. So let's look at the next example. So in triangle JKL, they've given us some information. So let's draw a triangle JKL. So if I have J, K, and L. Okay, side length J is 20, side length K is 18, and side length L is 16. It's asking us to find angle K. Okay, so if we're working with angle K, I'm going to circle that information that includes angle K. So again, we have this here. This is that information with angle K. And then we have side length K. That's all we've been given right now. So if we were going to rearrange this, we'd first write using the pattern of cosine law. We would have K squared. Let's make sure it's clear. That's a lowercase k. Equals, and then that would be J squared plus L squared. That's the Pythagorean theorem piece. Minus 2 times J and L. That's what's inside of our triangle, right? We have J, and this is L, times the cosine of capital K, right? So now we have that, but we need to solve for angle K. So we need to do some rearranging. So we're going to rearrange just like we did above. We're going to rearrange our cosine law. So I'm going to move the entire piece of this over to the left, and I'm going to move my K squared over to the right. So we will have 2JL times the cosine of K, because I added that to the left, is equal to J squared plus L squared minus K squared. Okay, and then we will divide both sides by that 2JL and take the cos inverse. So we're going to end up with angle K is equal to the cos inverse. I'm skipping a couple steps here because hopefully you can see what we did in that previous example. Divided by 2JL. I'm just going to highlight here so you can see the pattern again is going to stay the same. So here, in our previous example, right, we had b squared minus a squared, b squared plus c squared minus a squared, all over 2bc, and then we took the cos inverse of that. Notice that whatever angle we were solving for, that corresponding side was at this point on the right-hand side. So if we're doing the same thing for K, you can see that angle K is here, and its corresponding side, again, is in the same place as in the previous. right? And then the other two side lengths basically are just go in those other places. Oh, I noticed I missed a squared here, right? So BC were my other two side lengths up here. JL were my other two side lengths in the example we're looking at now. Okay, so let's plug in some values to this. So if we're trying to find angle K, we're going to do the cosine inverse of J squared. Well, 20 is J, and L squared, L is 16, minus K squared. Well, my side K is 18. All of that is going to be over 2 times J. J is 20, and L is 16. So we're going to have the cos inverse. If we calculate that entire fraction, make sure to calculate the top first and then divide by that bottom if we're doing order of operations. You should get 332 over 640 on the bottom. So angle K is going to equal 58.8 degrees when you do the cos inverse. So when you're finding an angle, again, the extra step is that we do have to rearrange cosine law, but if you become familiar with the pattern of what the rearranged cosine law looks like, then it's not too bad. And then of course you have to do the cos inverse at the end, just like you have to do the sine inverse for sine law. So a couple things to note here in terms of when do we use our cosine law. We use our cosine law when we've been given two sides and what we call the contained angle. Show you what I mean by contained angle. Let's see, are given, and we call this side angle side. So you see SAS because that means that's your side, your angle, and another side. So if I was to draw a triangle, and they gave us this side, and the angle between them, that's our contained angle because it's between the two sides that they gave us. That's why they call it the contained angle. Then that's when we use cosine law, and we saw that in the first example today. The other scenario where you'd use sine law is when you've been given all three sides, which is that last example we just did. So three sides are given. And we call this side, side, side. Okay, so we're going to look at one more example where we're solving the entire triangle. So we're trying to find all of our unknown side lengths and angles. So solve triangle DEF, given side D, side E, and side F. Let's draw this to start. Let's say D, E, and F. So side length D is equal to 6, side length E is equal to 7, and side length F is equal to 8. So like the previous example, we don't have any angles, so we could start by just deciding, well, which angle are we going to solve for? And we'll just keep it in order. Let's find angle D first. So remember, if we're trying to find angle D, I'm going to circle, making that kind of circular triangle. That triangle there that helps me find D, and then I'm going to point to side length D, so I remember that kind of pattern of my cosine law. I'm going to go ahead and write the rearranged version of cosine law, matching up with what we've done above. So if I wanted angle D, that means I would have to take the cos inverse of, inside my brackets, I would have my other two side lengths, which are in this triangle, so E and F. So E squared plus F squared minus, and then we'd minus from that our side length D squared. All of that is going to be over 2 times EF. So we'll plug in the values we have. So E is 7, F is 8, and D is 6. All over 2 times 7 times 8. So if you calculate the top, you should get 77, and on the bottom we should get 112. So to take the cos inverse of that fraction, you should get 46.6 degrees. Okay, now that I have angle D though, I'm just going to put it in here if I was right, 46.6 degrees. Well, now I have a side angle pair. So when I have a side angle pair, I can use sine law, which I would always recommend if possible because it's a little bit quicker than cosine law. Cosine law definitely is much more labor intensive. So let's find angle E now. Okay, so I'm going to use my sine law to do so. I'm going to set up the sine of E, because I'm trying to find an angle, over E. And then I'm going to set that equal to the ratio of side angle pair that I do have, which is for D. So the sine of D over D. So the sine of E over side length E, which is 7, equals the sine of angle D, which we just found in our previous step, over side length D, which is 6. I'm going to multiply that 7 up to the top. So 7 times the sine of 46.6 degrees all over 6. And then for angle E, I'm going to end up taking the sine inverse of that big fraction. When I calculate it, I should get 0.8477. Take the sine inverse of that and we should get 58.0 degrees. Okay, so we found angle D and E. The last one would be to find angle F. Now that we have two angles though, to find our third one, we just have to add them together and subtract from 180. So we will subtract the sum of our other two angles. So 46.6 degrees plus 58 degrees. Should get 75.4 degrees for angle F. So we have found now all of our angles. We didn't have any angles to begin with, and just using cosine law, then sine law, and then finally the sum of our interior angles, we were able to find all three angles. So that's it for your notes for today.